I know where there's some, right here in the hall, clerk.
No, Molly, not in there. I have
Here at the bottom, we've got the on-off power switch. We've got the zero adjust knob, which feels loose. This is what you would use to center the zero center DC volts meter here. The circuit selector, normal, AC peak to peak, and DC zero center here again. And what I suspect this does is when you switch to DC center voltage, it applies a bias voltage to the meter so that with no input, it will zero. With negative input, it'll go negative, and with positive, it'll go positive, as you might guess. This is the adjust ohms capacity knob here. So, I don't know what you're going to adjust. Maybe with if you short the leads, you can adjust this to zero on the meter. Could be. Let's go to the right-hand side. Okay, we've got a couple of lead inputs here, positive, negative for milliamps. The range selector is right here. It doesn't look like it's aligned. Well, it's hard to tell. Yeah, I guess it is. This outside scale is AC volts, DC volts, or mils, 3, 12, 30, 120, or 300. Down here, this scale is picofarads, microfarads, times 1 times 10. Here is microfarads. Divide by 100, divide by 10, times 1 times 10, and times 100. And that's for capacity. Did I leave anything else out here? I don't think so. Range selector. Function selector. AC volts, plus DC, minus DC, ohms, capacitance, and milliamps. Got a pilot light here with a bezel. This is for measuring ohms, so this is where the probes go in. There's a ground here. And you're measuring low ohms and or capacitance. So if you're measuring very low very low resistance, you would use ground and this connector. If you're usually using higher resistances or capacitance, you'd use the ground in this connector. This is the connector for the probe with the tube. For AC voltages here. I can't tell, just looking at this, looks like the DC voltage input. Yeah, so this would be the DC voltage input with the live lead and ground. And then there are 4 connectors here. And I've got to start looking for that connector somewhere for AC voltages. I'm guessing. I have to read I have to actually read the manual. I put a little crud cutter on a cloth and gave this a wipe right here to see if this was going to clean up okay, and it looks like it is. Got back to the original color, and it didn't lift the label for 1200 volts AC here. So I have hopes that this will clean up pretty well. So the next thing to do is to get this out of the case, and it looks like there are a bunch of Phillips screws around the outside edge here. Removing those should allow the case to slide off that way. The power cord comes out the front, as so none of the knobs have to be removed. But the next thing to do is take all this off, and we'll see what it looks like on the inside. So let's take these screws out. I know there are a couple of tubes in here, just looking briefly at the manual. I also know there were a couple of, I think, D-cell batteries in this at one point. I hope they're not still in there. I hope somebody took them out before they started leaking. The odds of that are pretty slim. I'm afraid we're going to see some battery acid corrosion in here. But we can deal with that, I suppose. But we'll do the usual stuff. I'll measure the DC resistance for the power transformer to make sure the power transformer appears to be in good shape. We'll go ahead and swap out the capacitors that need changing. We'll measure the resistors. As I also said in the first video, there are a bunch of precision resistors in here that will not get changed. Looks like I better lie this down or it'll fall out of the case. We don't want that in particular. Yeah, so precision resistors will not get changed because they're expensive unless they're burnt up, you know, but it's conceivable. I'm not sure. I'll have to do some research on the documentation. This measures 1200 volts AC, and there's a probe that goes there, but it looks like a standard probe. This is the one with the probe with the tube, the dual diode tube built into it. I can't imagine that there are any around, but it might be interesting to build one. The schematic I read is the schematic for that probe. That special probe is in the documentation. So we'll if everything else plays out and it looks like it's recoverable, we'll take a look at building a new probe for it. That might be fun. Okay, let me get this. Got this. Let me move the case over here. And here we go. Ooh. Well, it's pretty bad, but could have been worse, I guess. All right. Definitely battery damage. Let me show you. Okay, we've got a Rayovac industrial battery, it says here. And this one is an ever-ready heavy-duty battery. And it looks like the Rayovac didn't hold up as well as the ever-ready. On the other hand, this might be a lot older than this one. But it's really pretty badly corroded here, up underneath as well. Yeah, lots of green stuff. So this battery connection here sits on this phenolic board. It looks like phenol. It could be plastic. Not sure. Let's get a little more light on there. Oh, it does look like plastic. Yeah, so early 50s, this could easily be plastic on this plastic sheet. So I can get that off and just work on the battery system itself. But let's look around at the rest of it. We knew that was coming, right? You can hope against it, but there it is. Okay. I'm not sure anything's been done to this. I mean, that's an old waxy paper cap. Here's another one here. This looks like could be mica, although if it's, yeah, we'll have to look at that. I don't see anything. These are a bunch of resistors on this switch right here. This will be our precision resistors. A couple of coils, some carbon comp resistors throughout. This is that. I'm not sure. Early 50s, this could be a diode. Astron Corporation for this guy. It looks a bit like a capacitor, but it could be a diode. This one looks more like a diode to me. I can't quite read the maker's name. Anyway, we'll scope that out. These feel like paper, but I don't. This looks like a resistor, so might be some power resistors there. These guys are probably caps, mica caps. The controls along here. This control switch looks corroded because it's right below the batteries. So that will require some cleanup, I'm pretty sure. Up in here is our giant diode with a paper cap and our tubes are back under there. Presuming you can see them. There they are. So the power transformer is back in here. We've got 1, 2, 3 glass tubes and a metal tube hiding back in here. Looks like a filter cap, Mallory filter cap here. What's down in there? Looks like a rheostat back down in there. Yeah, maybe a couple of them. This looks like the back end of a rheostat. This might be as well. More old resistors that look pretty flaky and will probably need to be replaced. But as I said, our first order of business is to get this meter out and see if it works. There's some writing right here. Let me give you a close-up on that. I can see some pencil writing right here. And if we zoom in a bit, kind of illegible, but it looks to me like INSP, so inspected by MHG perhaps, and 62651 could be his inspector number or her inspector number. It doesn't appear to be a date. It could be a 62-651 right there. Hard to tell. Over here is another initial or a word AS here. Don't know what that means. And finally, at the battery connection right here, someone has written with a indelible marker 1.5 minus and plus, and then upside down from that, probably earlier, is VF06. And again, I don't have a clue what that means. There's a tube number right there, 6S right there. 6SN7. Let me zoom back out so I don't make you too sick. 6SJ7 is this guy, and the 6X5 is this guy. So, and then there's this one, which they didn't label. Interesting. Interesting. I can see it actually. It's a 6X5. So that's the tube complement. They'll plug into this chunk of sheet metal right here. It's not terribly dirty. The outside is kind of cruddy, but this is not bad. Outside of the corrosion for the battery, this is aluminum, this part. Well, let me get a magnet and make sure I know what I'm talking. Yeah, so this is steel, and this part down here in the corner, I'll show you. The meter is right here, and it has some metal in it. So if you go out to the edges of this large thing, it's not magnetic. So this is an aluminum plate with steel. It doesn't look like electrolysis is set in, corrosion between the aluminum and the steel, which is interesting. Wonder why that wouldn't be after this many years. But okay, I think we can go forward. What I will do, for starters, is remove the meter. I'll disconnect this capacitor. It's the only, and the two signal leads coming into it. I'll disconnect that from these posts in the back, and these four screws should allow us to lift the meter off the back. So we'll do that. But first, before I do that, I will take a whole bunch of reference photographs. I remind myself to do it, but in the rare times that I have forgotten to take reference photographs, I have regretted it so badly. So reference photographs for everything going on here. Well, for everything. I'll just take probably 50 reference photographs so that when I screw something up later, because I will, I'll have a photographic evidence of what it really should have been like as opposed to what I did to it. So I will stop here, take a bunch of reference photographs, and then we can start removing the meter. Let's see if we can get this meter out of there. We have the leads undone. We've released the mighty midget electrolytic capacitor. But let's see if we can lift this up and the meter stays behind. Indeed, here we are. Here's our giant meter. The good news is the springs. I'll show you a picture of how this movement works in a bit. But the springs are intact and not broken and not burnt up. Given that I want to paint this, and clean it up, I think I want to see if I can get the movement away from the metal here. And I think, having never taken one of these apart before, I think that'll be removing these 4 more nuts and this as well. Then this housing should lift off, leaving the movement behind. So let's talk a little bit about the movement in this meter. I presume it's a diarsenal, but we'll find out when we go to test it. Let's talk about how diarsenal movements work.